Good morning, students across New York State or wherever the heck you're watching this video from. I sincerely hope you're here for the Algebra 1 Common Core August 2015 solutions. Because that's what I'm here to do. I'm not quite awake yet. My voice is still cracking because I'm still asleep, since if you can tell down here, it is 4:46 in the morning. Actually, that's right behind my head, isn't it? You can't tell that. All right, it is 4. Maybe I'll move my head so you can actually prove that it is. But here, we're going to be doing parts 1. Oh, part 1. 1 through 12. Anyway, all of this material can be found at www.mrkraussemath.com. There's a link somewhere down there in the show notes. It's really well organized for you. It's all under Regents Review. They got a copy of the test. They got a copy of the multiple choice answers, and the video's broken down for you. And then it's for all exams. And if you remember, bookmark that page, you won't have to know where to go. And it'll be there for when you get to Algebra 2, and perhaps if I even start working on the geometry exams. Who knows? At any rate, I hope you're here to learn. I hope you're here to learn something from me, and I hope you're not here just to cheat and copy the answers. I know I say that every video. If you watch a lot of my videos, I say that because it's true. It's true. So you got to try, and you got to struggle, and you do it. And if you get a 100% on the Regents exam, and I helped you in any way, shape, or form, you can go on my wall of fame. You can go on my wall of fame, but you have to provide proof. Well, I can't talk. Proof that you got 100. You guys ready to rock? I'm ready to roll. Let's do it. All right, so here we go. Problem number 1. Given the graph of the line represented by the equation f of x equals negative 2x plus b is increased by 4 units. Basically, they're just going to add 4 units on. The graph of the new line would be shifted 4 units too. So really, we're just adding 4 units onto the y-intercept. So if we add 4 units onto the y-intercept, it's going to go up 4 units. I circled down and said up. Woo! It's going to be a rough video, kids. Let's try up. It's going to go up 4 units. Yes, it's definitely going to go up 4 units. And I circled up. Yay! Oh my goodness. All right. Rowan. Did I say it right? Rowan? Rowan. It's kind of a cool name. All right, Rowan. I think you can see it better like this. All right, there we go. Has $50 in his savings account and is putting in $5 a week. So if we talk about Rowan, he's got $50, and you're going to hear me talk about this every week, per week. This is the multiplied thing. This is the thing that's getting multiplied. As soon as you hear the words per or every or whatever, monthly, that's the thing that's going to get multiplied. So every week he's putting $5 in. And he's got Jonah has $10 in his jar, so Jonah is starting with $10, and he's adding in $15 every week, so 15x. Now, if I didn't want to use x, I could use w for weeks. Which statement is true about their graphs? Well, let's see. Ronan's graph has a steeper slope. The steeper slope is right here, 15. That's 15 over 1, and this is 5 over 1, so that's not true. Ronan's graph always lies above Jonah. It starts above it. It's going to start above it, but because this one's got a steeper slope, this one's going to grow a lot faster. So eventually, Jonah, in not too short a time, will catch up in about 5 weeks. Jonah's graph has a steeper slope than that's true. And Jonah's graph always lies above Rona. The problem is not until week 4. It starts out below and then eventually gets above. So there's your answer, chillin'. To watch a varsity basketball game, the spectators must buy a ticket at the door. The cost of an adult ticket is $3, so we'll do 3 times adult. And the cost of a student ticket is just slightly too big. The cost of a student ticket is $1.50, so we'll add in $1.50 for the student tickets. If the number of adult tickets is A, I guess, and the student ticket is S, which expression represents the amount of money collected at the door? And they put questions like that on the test, and then they're going to come out later and they're going to zing you like crazy with one of these hard problems, I'm sure. They love to do that stuff. So the graph of f of x is shown below. Which function could represent the graph of x of x? Well, let's do a couple things. Let's figure out what the roots are. Roots are -4, -2, and 1. So if the roots are -4, 2, and 1, let's talk about what that means. Let's talk about what that means to be the roots. At some point, this thing got factored. You see off to the left here, they look like they tried to factor it a little bit. At some point, this thing got factored. And then the roots were x equals -4, x equals -2, and x equals +1. And I got those from looking here. Roots, +1, -2, -4. Now, where did those go when you go backwards? We're going to try to go backwards here. When you go backwards, those come from x plus 4, x plus 2, x minus 1. So those are the 3 factors. Be careful what the words are. These are the factors. These are what's called the roots or zeros. They're also called the x-intercepts. So you got to know a lot of stuff. But for the most part, you'll either hear roots or zeros. Which function could be the graph? So we're looking for something with, this one has an x plus 2, this x minus 2. This doesn't have an x minus 2, and it doesn't have an x minus 2. So it's got to have this x plus 2, and then it looks like they put these two things together. So if I double distribute x plus 4, x minus 1, I get x squared plus 4x minus x minus 4. And that would have to be that one right there. There we go, kids. The cost of a pack of chewing gum in a vending machine. So chewing gum, maybe I should just call it gum. You guys get over it. Gum is 75 cents. Juice, J, is $1.25. Julia has $22 to spend. So whenever you have $22 to spend, you have to stay less than or equal to that. Oh, look at that. Greater than or equal to, greater than or equal to. All right, down to 2 choices. If B represents, she has to buy 7 packs of gum. I guess she's getting them for her friend. So you know we're going to take 75 cents and we're going to multiply it by 7. And then we got to buy, we want to buy as much juice as possible. Now, I'm not sure. Was it B for bottles of juice, I guess? So to that, we're going to add $1.25 for the bottles of juice, and we have to stay under 22 bucks. And that would be choice 4. Choice 4, kids. So far, not too bad. So far, not too bad. They always start out easy, don't they? And then all of a sudden, they just go like, where did that problem come from, and why are you giving that to me on an Algebra 1 exam? But when that happens, I bust out the Dunkin' Donuts coffee from Rochester, New York, because they love Rochester, New York. By the way, I don't teach in Rochester. I teach in Hilton, New York, which is right outside of Rochester. All right, so let's see what we got here. First things first. We've got a solid line and a solid line. And all 4 have solid lines. Son of a gun, that would have been easy. Okay, 1's less than, 1's greater than. All right, let's just go through it. This one has a y-intercept of 3, and it's going up. So y-intercept of 3, and it's going up and over. That's the right line. That's the correct line. But this says less than, so that can't be right. So we got rid of that one. This one says, so it's got the right line, and it's shading down. So far that one's pretty good. Let's check the other line. -2, and it's going down 2 and to the right one, down to, so that's right, and it's shading greater than. This looks like the right answer. Let's just check real quick. So this has the right line here. Where did I go? This has the right line here, but it's shading down, and this one's greater than, so we don't want that one. And this one's got, they both have the right lines here, but again, this one's shading up, and it should be shading down. So the answer is choice 3. Tough problem. Oh, I said tough problem. I really didn't mean that. It's actually kind of an easy problem. But on the TI Inspire, if you have this calculator, I hope most of you have this calculator, you can go hit the back button here, change this to less than or equal to, and then type in x plus 3 and get some shading. And then you could type it in and hit tab and type back up. Hit greater than or equal to, which is 5, and do -2x minus 2 and hit enter, and you'll see, try to match the one up that looks like that, you know, and that's the one we picked. All right, kids, we're done with that. That problem's over. The country of Benin in West Africa has 9.5 million people, and the population is growing at 3.1%. Now, anytime I see a 3.3 percentage, I want to convert that to a decimal, and I want to make sure you just be careful. Always remember, 10% is equal to 0.10. So anytime you do a percentage, and they're almost always less than 10%, and this is 3%. So 3% would be not 0.3, but 0.03. It's got to be less than this. And then if we go 3.1%, what we do is you say, okay, you're going to start with 3%, and then we tag on the 1. So this is 3.1%. Just be careful about the way that's written. All right. And we're going for 7 years. So which function can be used to find the population after 7 years? You guys didn't. Oh, okay. All right, so never mind. I thought they were going to like screw us up with scientific notation. So these are all the same. So these make no difference whatsoever. They just don't make any difference. The only thing we're going to worry about is this right here. And we just talked about it's not 0.31, so those have to go. So it's one of these two. And is it growing? It's growing. And if something is growing, we're going to add it up. So this is the key right here. We're going to add it up. So here's our winner, number 3. Next problem, what are we going to? Number 8. See, you always know you're doing a Common Core test when there's like 12 sentences. If you've got a 12 sentence question, it's got to be Common Core, because the more sentences, the more difficult it is, and therefore it's Common Core. Come on. We used to ask this question like 2 sentences. Same question. And I don't know, mathematicians like short sentences. I hate when people tell me a story and they're like, and then she raised her arm slightly before she turned to address the crowd, but before that she had to tie her shoe. Who cares? Don't tell me all that stuff. I don't care. It's the same thing with these problems. I got all. A typical cell phone plan has a fixed fee that is in a certain amount of data to overage for the beyond plan. A cell phone plan charges $62 and overcharges of 30 gigs per gig that exceed 2 gigabytes. If C represents the cost of and G represents the number of gigabytes, which equation could be represented as planned more than once? Now, here's another one of these examples, and I've seen these on a lot of exams, where they want you to start with a certain amount, like $62, and to it we're going to add $30 per gigabyte. But, and again, this is another one of these ones where they're only when you get above 2 gigs. And anytime they start with a problem like this, and you're going to see it on a lot of these Algebra 1 Regents exams, you have to get rid of the original 2 gigabytes because you're not multiplying by 30 to those. You're only multiplying by only the gigs that are above 30. And when they get a problem like that, you have to put the gigabyte usage in parentheses and subtract it off. So there's the equation. Not sure which one it is. Looks like it might be 2. Sometimes I circle the wrong answer. Is that right? You got to be so careful, man. I'm like G minus 2. We're multiplying. We're adding. Looks good. Totally not the right answer. This is the right answer, I believe, right? 62 plus 30 times G minus 2. There's the right answer. Ka-ching. Just be careful of that. Anytime they're going to charge you after something, then you're going to see something in parentheses like this where we're subtracting off the ones that they're not going to charge us for. Tricky, 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 tricky. 4 expressions are shown below. The expression is equivalent to. Okay, so we want to see how many of these are equivalent to this expression. Not a dumb question, but we're going to distribute this too. So 4x squared minus 4x minus 120. Yep. Now we're going to distribute to 4. 4x squared minus 4x minus 120. Yep. Oh, now we got to double distribute, then distribute to 4. So let's do that first. So that's x squared, and that's minus 30. Now these give me, negative 5x. And this is positive 6x, so plus 6x. So that's plus x. Oh, it's plus x. So when I distribute here, that'll be plus 4x. So that one's not going to work. The other two work fine. And now 4x squared minus 4x minus 120. Ka-ching. So 1, 2, and 4. Let me make sure I circle the right one. Choice 3. 1, 2, and 4 is the big wiener. Last week at Candle Store received 365. They sold 20 candles. They sold small candles. So the small candles plus the large candles has to equal 20 candles. They sold the small ones for $10.98, $10.98 for the small candles, and $27.98 for the large candles. And they made a total of $355.60. This one's definitely a calculator question. So let's assume for fun, I always assume at the end, I always try the end. So let's assume that it's this answer, 12. 12 for the number of large candles. So 12 here, that would make 8 here. And I'm going to try that in my calculator. So 1098. So 10.98 times 8 plus 27.98 times 12. Now we just assumed it was 12. Well, you don't know it. I had to take a little break. For some reason my calculator just shut down for me, but I think I got back out 10.98 times 8 and 27.98 times 12, and we get a total of $423. Way too much. So let's try the next one, and the next one would be, that didn't work, 10 and 10. I probably should have started with 10 and 10. That would have been a great place to start, actually. So we'll go to, I always just try to start at, so we'll start here at 10. Ding, 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 ding. Go over here to 10 and try that. We're looking for 300, nope. And the next one was 8. The next one was 8 large candles, so we'll go to 8 large candles. So times 8, which if this is 8, then this over here would be 12. 355, 60, 355, 60. There it is. The winner is 8. Not you guys. All right, kids, that's 10. 2 more to go in this video, and then you got to check the next video out. Remember, MrKrausemath.com. I've got them nice and organized for you. So which of the following representations are in fact functions. So, if it's given to you in list form or in a table form like this, what you're looking for is repeating x values. If you have repeating x values, then it is not a function. So that's the first 2, 3, 4, 5, 2. Oh, we got a 2 here and a 2 here. And they map to different functions, so this is not an answer. When you're looking at it graphically, like this one, you're looking to see, does it pass the VLT, the vertical line test? And it fails the vertical line test because as soon as I draw in a vertical line, I hit it more than once. Again, this is just another listing format. And I'm looking for repeating x values. Nope, 1, 2, 3, 4, 5, 6, 7. So this is one. So anything that doesn't have 2 in it's got to go. So now we just got it, and 1 we decided was not 1. So clearly 4 must be a function. And since it's just a line with a slope of 2, that's a function. There it is. So I'm going to do this mathematically and algebraically for you, and then I'm going to show you how to use the calculator to do it as well. So all we got to do is plug in 1/2 for x. Now multiplying by 1/2 is just taking half of the thing. So when I take half of, so it's 2 times 1/2 plus 3 all over 6 times 1/2 minus 5. Well, remember, multiplying by 1/2 is just taking half of something. So what I'm going to end up with here is half of 2 is 1, 1 plus 3, all over half of 6 is 3, 3 minus 5. So the numerator, this is really just a 4. The square root of 4 is 2. And 3 minus 5 is negative 2. So that is just negative 1 is my answer. Now, having said that, I would not really generally recommend you doing it that way, although great, love it. But if I can do it on my calculator, I think I'll do it on my calculator. So let me blow this up for you so you can see what I'm doing here, because it's the last thing I'm doing anyway, on this video at least. 200%. Okay. So what I'm going to do is I'm going to take a half, 1 divided by 2, and I'm going to store it into x. You can do this on the 84 as well. It just doesn't have the nice looking format for this. So we're going to do square root of 2x plus 3. That's what it was. 6x minus 5. And hit enter. And look at that. Negative 1. Boom. Ding, ding, ding. Done. All right, kids. That's it. Check back for the next video. Again, go to www.mrkraussemath.com. There's a direct link to this, and look for Regents Review. Underneath there, you'll see Algebra 1. In there has a listing of all the Regents exams in order, the way they were given, the exam, the multiple choice answers, as well as all of my solution videos for all of these things. And it's nice and organized, the easiest way to find me. All right, kids, good luck. See you on the next video, kids. Bye. Oh, I got to say goodbye. Bye.